In today's video, we are going to be running a repeated measures ANOVA looking at anxiety ratings. So we have 10 participants who measured their anxiety before taking medication, 1 week into taking medication, and 2 weeks after taking medication. Anxiety ratings are measured on a 1 to 10 scale, with 1 being no anxiety or low anxiety and 10 being extreme anxiety. We also queried our participants on their sex, male or female, and recorded that. And we also want to see if there are any sex differences in the amount of anxiety they experience throughout the treatment. So what we will do now is we will go to Analyze, General Linear Model, Repeated Measures. In this window, we will define our factor, so you can rename it or you can leave it as factor 1. It's asking you how many levels. We have 3 levels, the before, week 1, and week 2 treatment. And then we click add. And then we want to give our measure a name. So this is going to be time. Click add and then click define. Now we need to tell SPSS which variable is at time 1, which is at time 2, and which is at time 3. So we will select the B before treatment and move it over, the W1, which is week 1 treatment, and move it to time 2, and W2, which is time 3. In this example, we do have a grouping variable or an independent variable, which is sex for us. So we want to move that into the between subjects factors box. Now we're going to click options, and we want descriptive statistics, estimates of effect size, and homogeneity tests. Click continue. This is normally going to be under the EM means tab if you are running a newer version of SPSS. Sometimes it's in the options tab if you're on an older version. So we'll click EM means. We will grab our factor 1 since it has 3 levels and move it over into the display means 4. We want to compare our main effects and we want to do a Bonferroni adjustment. Then click continue. We also want to ask for plots. So we will select plots. I always like to put the variable that has the fewer number of levels on the separate lines. So for us, sex has 2 different levels, male and female, and factor 1, which is our time, has 3 different levels: before treatment, 1 week after treatment, and 2 weeks after treatment. So we'll move sex over to the separate lines and factor 1 over to the horizontal axis. We then click add and continue. One more thing to note is if your between subjects factor, so ours for sex, actually had 3 different levels, maybe you were looking at differences by grade, 4th, 5th, or 6th grade, and so you had 3 different levels, you would need to run post hoc tests, which you would select post hoc. You would move your variable over here and you would most likely select 2 key, but there are multiple other ones that you can select. Our between subjects factor or independent variable only has 2 levels, so we will not need to run post hoc tests on it. Then click OK, and we will examine our output. At the top, we have our within subjects factors, between subjects factors, and descriptive statistics tables. These, of course, the first one just tells us what are 3 variables that are associated with the measure of time before week 1 and week 2. Tells us how many participants we have in our 2 different levels of our independent variable sex, 5 male, 5 female. And then it breaks down their average anxiety rating by treatment time. Following that, we have Box's test of equality of covariance matrices. We're not going to get into it, but essentially it's one of the assumptions underlying a repeated measures ANOVA when there are independent variables involved, and we want our significance level to be greater than our alpha of 0.05. So in this example, we do meet that assumption of equality of covariance. Then we'll scroll down, and our next assumption is our assumption of sphericity. We'll look at the Maltese test of sphericity, and we can see that it has a significance value of 0.787, indicating that we do meet the assumption. And our test statistic is Maltese W of 0.934 with 2 degrees of freedom. Finally, there's a last assumption of our repeated measures ANOVA with an independent variable, and it's the Levene's test of homogeneity of variance. Very similar to the ones that we've been running in all other ANOVAs. However, what it's doing now is it is testing if there are significant differences in the variation for boys and girls at each of the 3 different time points. So for the Before medication, we can see that there are no significant differences based on sex. At time 1, again, there are no significant differences in the variance of anxiety rating at time 2. And again, at time 3, there are no significant differences in the variance of anxiety ratings for male versus female patients. So now what we're going to do is we're going to go up and look at our test of within subjects effects. This is going to be the one that we are interested in for answering our main question. Is there a difference in anxiety ratings over time after taking medication? So we want to look at our time factor, which we left as factor 1, and we did assume sphericity. So we will be looking at the top row. We can see that there is a sum of squares of 113.27 with 2 degrees of freedom, which gives us a mean square of 56.33. And if we take that by our error mean squared, which is 0.625, we get our F statistic of 90.61 with a p-value of less than 0.001. So we know that there are significant differences in the anxiety ratings over the 3 different time periods. Again, just like before, we don't know where these differences lie, so we will have to run post hoc tests in order to determine where the differences are. We also want to look at our interaction effect between time and sex. And again, we're going to be looking at our top row where sphericity is assumed. We can see that we have a mean squared of 1.033. We have 2 degrees of freedom. Our F statistic is 1.653, and our p-value is 0.222, indicating that we do not have a significant interaction effect between sex and time on anxiety ratings. Now what we'll go down and do is look at our between subjects test. This is going to tell us if there is a significant difference in average anxiety rating across the 3 times for males and females. So it's looking at all 3 times together and then just comparing male and female anxiety ratings on average. And so for this test, we can see that we have an F statistic of 4.91 with 1 and 8 degrees of freedom, and we have a p-value that is greater than our alpha of 0.05, and our p-value is 0.058. So we do not see any significant differences between males and females in their average anxiety rating. Now, we can also go down here and look at our profile plots, and we can see it's going to create a different line for the ones that we asked for separate lines for, which was sex, so male are blue and female are red, and we can see that across the 3 times, it declined for each time period measured. While there is a little bit of a difference between the normal distance between male and female ratings at time 2 compared to the other 2 times, in general, they do follow each other in a very parallel manner, which replicates our findings that there's no interaction effect between sex and time. So now we will go up and we will examine our estimated marginal means. We are doing this because we needed to run post hoc tests to determine where the differences lie between the 3 time periods. So this is going to give us our descriptive statistics under the estimates table. We can see that at time 1, the average anxiety rating was 7.5 for all participants. At time 2, it was 5.8, and at time 3, it was 2.8, indicating that there was a decrease at each time period. So then we'll go into our pairwise comparisons table, and we'll see that time 1 compared to time 2, there is a statistically significant difference between the anxiety ratings with a p-value of 0.002. Between time 1 and time 3, it's a p-value of lower than 0.001, and again between times 2 and time 3, it is again statistically significant with a p-value less than 0.001, indicating that at all 3 pairs, there is a statistically significant decline, as we can see through our descriptive statistics, of anxiety rating for males and females. One thing to note is that if your sphericity was not assumed in your analysis, there are 3 other types of corrections and estimations that you can make to still conduct a repeated measures ANOVA. They're the greenhouse geyser, the wind felt, and the lower bound estimates of a lower bound. All of these are outside the scope of this course, but if you do see on a later analysis that you do not meet the assumption of sphericity, those are definitely options to investigate to see if they might be a better analysis for your data set.